Hello and welcome back. So far we have understood, linear algebra. As part of linear algebra, we understood eigenvalues, eigenvectors and singular value decomposition. So in dimensionality reduction, we'll use eigenvalues, eigenvectors or singular value decomposition. So first of all, let us try to understand what is curse of dimensionality and then what is dimensionality reduction, and then we'll understand an algorithm called as principal component analysis and how it will help us reduce the dimensionality. So the curse of dimensionality is that in many machine learning problems, we'll have thousands and millions of features, and if you have too many features, right, it will be difficult for a to build a model or train a model on a local machine, because you will have limited amount of RAM and processor. That is one problem. So the second problem is, selecting best features is going to be a bit difficult thing. We can use regularization, and in random forest we have best features. Those things are there, but still it is going to become difficult because of processing power and RAM. So this is often called as the curse of dimensionality. For a machine learning algorithm, it's a curse of dimensionality. So to avoid this or to reduce this problem, we can use dimensionality reduction techniques. What is dimensionality reduction? Reducing number of features with minimal information loss is called as dimensionality reduction. We are trying to reduce 100,000 feature data, 100,000 column data into maybe 100 or 1000 or maybe maybe 1050. We are trying to reduce the dimensionality, reduce number of columns with minimum amount of loss of information. So when you have n number of features, right, those features will have importance, right? They will have essence in them which actually makes the model understand the pattern and recognize the pattern between the input and output variable and makes the prediction well, right? So if you remove some features, you may lose information. So instead of removing the features, the dimensionality reduction techniques will try to extract essence from data and then create less number of features. If I have to simply explain, in eigenvalues, eigenvectors concept, we said that we are going to take covariance matrix of your original data and then do eigen decomposition. The covariance matrix, we are going to do eigen decomposition, where it extracts the covariance existing in the dataset, and we are going to reduce the number of columns using the covariance extracted from the data. So this is one example. So this is how principal component analysis works. Okay. So if you look at the data set here, the data set may have had 100,000 columns. When we apply PCA, it actually becomes like Z1, Z2 and so on, Z100. 100 is a random number I have chosen. You can do it 50 columns or 100 columns or 200 columns or any number of columns. You can reduce the dimensionality and make the data set a little smaller with similar information. It is like this. When you reduce dimensionality, there will be information loss, but it is going to be minimal. It is like when you reduce an image to a JPG format, you will lose some information, but still you can understand that the picture will be clear to see, right? So that's how the principal component analysis works. The principal component analysis is an algorithm which helps you reduce the dimensionality with the minimal information loss. So we'll see how it works and what are the internal details of it in our coming session. Thank you.